This is a demonstration of the new LEX 1000 from EMX Industries. The LEX 1000 measures the color of light from a wide variety of light-emitting sources. We're going to demonstrate today a blue LED, which is connected to a power supply, and the LEX 1000 is connected via an I/O box and a USB port to the computer. The sensor comes with a Windows application program that allows you to control various settings on the sensor. The sensor provides RGB levels of the light that is being collected and focused onto its receiving element. The sensor has 4 programmable color channels. So if I go to channel 1 and I select adjust tolerance for the red, the green, the blue channels. We'll do that real quick here. We're going to set them for 20% tolerance. And also for the blue channel. And we will program that, and the sensor will remember the RGB levels and activate channel 1's output as indicated by the LED whenever there's a match. So if I interrupt the light, the sensor PNP, NPN output switches on and off. This particular model has 4 programmable channels, and each one can be programmed for a different color, and each one has a separate discrete output pin that can be tied into a PLC. Also, the sensor can measure, as I said, a wide variety of other light sources. We're going to look at a cell phone screen, and you can see the red signal level from the picture on the cell phone screen and the blue LED. And also we have several examples that we can show on the monitor. Right now we are looking at a black screen on the monitor. You can see the RGB signal levels are relatively low. Change that to a white screen. RGB signal levels go much higher. It's a red screen, predominantly a red indication, and a blue screen, much higher blue component. Green screen, combination of red and green output. So that's the LEX 1000 sensor. Again, it can measure a wide variety of light sources, can measure ambient light, office lighting, tungsten lamps, and many other items. So that's a demonstration of the LEX 1000 from EMX Industries. Okay, here's the BrightX sensor. The sensor has a display relative signal level from 0 through 99. There is the sensor's light spot on a white sheet of paper. You can see the red LED turns on when the signal level is above the threshold. That also causes the discrete output to activate. So here's the signal along the edge of the box. And you'll see the signal go up significantly when it hits the highly reflective tape. There's one side. There's the other side. This is a demonstration of the BrightX Model 1000S sugar color sensor from EMX Industries. The BrightX 1000S is designed to measure raw or refined Tecumseh sugar color online at a lower cost than competing systems. The BrightX employs our field-proven patented technology for effective reflectance measurements of sugar. The monitoring of sugar color allows processes to operate in a more efficient manner while increasing throughput to meet market demands for high color quality. The sensor features a high sensitivity receiver, a blue
457 nanometer light source, and a 2-digit display, which is an indication of the signal strength or the amount of light that's reflected back from a target surface. There are internally several settings in the menu for setting the light source intensity, as well as gain settings for optimizing the sensor in a specific application. The red LED is indicating the status of a discrete output, which is NPN or PNP, for direct connection to a PLC or other control equipment. And the discrete output is a threshold-based output. Whenever the signal level exceeds the threshold, the output activates. And this is high speed. The response time is approximately 100 microseconds. The display 0 to 99 display is an indication of the relative intensity of the light that's reflected from the surface of the target. So right now we're reading around 38. If we look at a light color target, the white copy paper, we're reading much higher in the 80s. And we can see that the discrete output is activating and deactivating as we cross the threshold. The sensor also features a 0 to 5 volt analog output, which can be connected to any kind of process equipment where an analog input can be provided. And that signal can be correlated to the ICUMSA sugar values, as we will see in our demonstration. This is a display for the BrightX sensor to show ICUMSA color of several different samples of sugar. These samples range from table sugar to approximately 17 or 1800 ICUMSA. We'll start with the table sugar. We have the sensor connected directly to an HMI device, and we've correlated the analog output, the 0 to 5 volt analog output from the sensor to ICUMSA values. So right now our standard white table sugar is measuring around 35, 36. A little bit darker, lower grade is measuring around 142. Again, a little darker, 847, 846. Again, darker, 1390s. And finally, the darkest sample we have around 1700. So the sensor output can be connected, as I said, a 0 to 5 volt analog signal. It could be connected to any external equipment that can take an analog input, and then those levels can be correlated to ICUMSA values and shared with other processing equipment in a facility. And that is the demo for the BrightX 1000S sugar sensor.